Across the unfathomable stillness of the cosmos, there is a secret current. It is a motion so vast, so inexorable, that it escapes our everyday perception. We feel the solid ground beneath our feet. We see the sun rise and set. We chart the stately procession of the stars across the night sky. Everything seems rooted in a celestial permanence, a dependable clockwork order. Yet this sensation of stability is a profound illusion. Our planet, our sun, our entire galactic home are all caught in a cosmic drift. We are passengers on a river of space-time, being pulled by an unseen force, a force of such magnitude that it tugs on 100,000 galaxies at once. This is not the gentle, uniform expansion of the universe, pushing everything apart. This is something else, a deviation from the grand cosmic blueprint. It is a specific, directed, and relentless pull toward a single, mysterious point in the southern sky. For decades, we did not even know it existed. We sailed through the void, oblivious to the destination toward which we are hurtling, a destination hidden behind a veil of our own making. This is the story of a gravitational anomaly, a ghost in the cosmic machine, a mystery that, in our attempts to solve it, completely redrew the map of our universe. This is the story of the great Attractor, and the even greater enigmas that lie beyond. Our tale begins not with a single discovery, but with a dawning, unsettling awareness. In the mid-20th century, cosmology had achieved a kind of elegant simplicity. Edwin Hubble had shown us that the universe was expanding. Galaxies, great islands of stars, were all receding from one another. Like raisins in a rising loaf of bread, the fabric of space-time itself was stretching. This cosmic expansion, the Hubble flow, became the bedrock of modern cosmology. It predicted that, on the largest scales, the movement of galaxies should be uniform. Their velocity away from us should be directly proportional to their distance. And for the most part, the universe seemed to play by these rules. But science thrives on the exceptions, the tiny discrepancies that whisper of a deeper truth. By the 1970s, astronomers had developed increasingly precise methods to measure cosmic distances. They could now begin to untangle a galaxy's motion through space from the motion of space itself. This personal, localized movement is known as peculiar velocity. Imagine a flotilla of boats drifting out from a central point on a perfectly even tide. That tide is the Hubble expansion, but now imagine each boat has its own small motor and a captain with their own agenda. Some boats might be moving slightly faster or slower than the tide. Some might even be veering off to one side, nudged by a local current. That extra, individual motion is the peculiar velocity. When astronomers started measuring these peculiar velocities, they found something astonishing. The boats in our cosmic flotilla were not moving randomly. A significant number of them, including our own Milky Way, all had their motors pointed in roughly the same direction. Our local group of galaxies, the Virgo supercluster, the Hydra Centaurus supercluster. Everything within a swath of space, hundreds of millions of light years across. All of it was streaming at a staggering 600 kilometers per second toward a single area. It was a coordinated, large-scale flow, a cosmic conspiracy of motion. The universe was not a uniform, expanding loaf of bread after all. It was a landscape with gravitational valleys and mountains, and we, along with our countless neighbors, were all sliding downhill into the same colossal basin. The question was, what or who was at the bottom of it? The challenge fell to a group of 7 astronomers in the 1980s. Their collaboration would become so legendary, they earned an enduring nickname, the 7 Samurai. Alan Dressler, Sandra Faber, Donald Lyndon Bell, David Burstein, Roger Davis, Roberto Terlevich, and Gary Wiegner. They embarked on an ambitious, painstaking campaign to map this strange cosmic current. Their method was both brilliant and arduous. They studied a specific type of galaxy, the elliptical galaxy, which is older and more uniform. They discovered a relationship between the brightness of an elliptical galaxy and how fast its stars were moving. This relationship, known as the Faber-Jackson relation, allowed them to calculate a galaxy's intrinsic luminosity. It was like knowing that all 100 watt light bulbs have the same true brightness. By measuring how dim a distant 100 watt bulb appears, you can precisely calculate its distance. The Seven Samurai used elliptical galaxies as their standard light bulbs, their cosmic yardsticks. They could now measure a galaxy's distance with unprecedented accuracy. Then, they measured each galaxy's redshift, the stretching of its light due to its motion away from us. This redshift had two components: the part from the universe's expansion and the part from its peculiar velocity. Since they now knew the precise distance, they could calculate the expected redshift from expansion alone. Anything left over, any extra redshift, or even a blue shift, was the galaxy's own peculiar motion. For 6 years, they pointed their telescopes to the southern skies, gathering data from over 400 galaxies. It was a monumental feat of observational astronomy, a meticulous survey of our cosmic neighborhood. As the data points accumulated, a picture began to emerge from the statistical noise, a picture that was both breathtaking and deeply mysterious. Their map showed a coherent flow, a river of galaxies, and at the heart of that flow, where all the currents converged, was a nexus of immense gravity. They had located the source of the pull. It was a concentration of mass, equivalent to tens of quadrillions of suns. An object so colossal, it was warping the space-time around it for hundreds of millions of light-years. They gave this unseen entity a name worthy of its scale and its mystery: the Great Attractor. Pinpointing the location of this cosmic behemoth presented a formidable challenge. The Great Attractor was located in the direction of the constellations Centaurus and Norma. Unfortunately, this placed it directly behind the plane of our own Milky Way galaxy. This swath of the sky, teeming with stars, gas, and thick dust, is known to astronomers as the Zone of Avoidance. It is our galaxy's own obscuring fog bank, a curtain of material that blocks our view of the deep universe beyond. Trying to observe the Great Attractor with visible light telescopes was like trying to see a distant mountain range through a blizzard. We could feel its influence, the gravitational pull that tugs on our own galaxy. We could see its effects on the galaxies around us, like watching leaves swirl around an invisible drain. But the source itself remained shrouded, a phantom lurking just beyond our sight. This cosmic game of hide-and-seek forced astronomers to become more creative. They had to find ways to peer through the galactic veil. The solution lay in observing the universe in wavelengths of light that are invisible to the human eye. Infrared light, for instance, is better at penetrating dust clouds than visible light. Infrared surveys began to reveal the dim glow of previously hidden galaxies in that direction. Radio waves, with their long wavelengths, could pass through the dust almost entirely unimpeded. Radio telescopes mapped the distribution of hydrogen gas, tracing the faint outlines of galactic structures. But the most powerful tool for piercing the gloom was X-ray astronomy. Galaxy clusters are not just collections of stars, they are filled with enormous clouds of superheated gas at temperatures of millions of degrees. This impossibly hot gas shines brightly not in visible light, but in X-rays. And X-rays, like radio waves, can slice through the Milky Way's dust with ease. When X-ray telescopes were pointed toward the suspected location of the Great Attractor, they saw it. Not a single object, but a vast, sprawling conglomeration of galaxies. At its core lay the Norma cluster, a rich and massive galaxy cluster in its own right. But it was clear that the Norma cluster was just one part of a much larger superstructure. The Great Attractor was not a single, monstrous thing. It was a gravitational focal point, a basin where numerous filaments of the cosmic web converged, a cosmic city center, drawing in matter from the surrounding galactic suburbs. It was a diffuse, sprawling overdensity of dark matter, hot gas, and thousands upon thousands of galaxies. The mystery seemed to be solved. We were being pulled by a colossal collection of cosmic matter hidden behind our own galaxy's glare. Our journey across the cosmos had a destination. But the universe is rarely so simple. As our maps grew more detailed and our understanding more profound, a new complication arose. The solution to the first mystery was about to become the prelude to an even greater one. The discovery of the Great Attractor was a landmark achievement. It revealed the lumpy, uneven texture of the universe and the power of gravity on immense scales. It seemed to provide a complete explanation for our galaxy's peculiar motion. However, a nagging question persisted among cosmologists. The calculated mass of the Great Attractor, vast as it was, didn't seem quite enough. Based on the best estimates from the visible galaxies and the X-ray emitting gas, it accounted for a significant portion of our motion, but not all of it. There was still a residual velocity, a remaining component of our cosmic trajectory that was left unexplained. It was as if we had discovered the powerful river current pulling our boat, but we then realized the entire river itself was flowing downhill. The Great Attractor was just a local waypoint, not the ultimate destination. The entire system, our galaxy, the local group, the Virgo supercluster, and the Great Attractor itself. This whole enormous volume of space was part of an even grander, more majestic flow. To understand this, we need to redefine what we mean by here in the universe. For decades, we defined our cosmic address by proximity. We lived on Earth, in the solar system, in the Milky Way galaxy, in the local group, which was part of the Virgo supercluster. This was a nested hierarchy based on physical grouping. But in 2014, a team led by astronomer Brent Tully proposed a revolutionary new way to map the cosmos. Instead of grouping galaxies by how close they are, they grouped them by where they are going. They mapped the gravitational flows, the paths that galaxies take as they fall towards centers of mass. They defined a supercluster not as a simple collection of matter, but as a gravitational basin. Imagine a watershed on Earth. Every drop of rain that falls within that watershed will eventually flow into the same river and end up in the same basin. Tully's team applied this concept to the universe. They mapped the peculiar velocities of tens of thousands of galaxies. They drew the gravitational boundary lines, the cosmic equivalents of continental divides. On one side of the line, a galaxy would fall toward one supercluster. On the other side, it would fall toward another. When they mapped our local region, they made a stunning discovery. The Virgo supercluster, which we had long considered our home, was just a small province. It was merely an outlying suburb of a much grander structure. Our Milky Way, the Great Attractor, and roughly 100,000 other galaxies all belonged to a single, vast gravitational basin, a supercluster of unimaginable proportions, stretching over 520 million light-years from end to end. They gave this colossal structure a Hawaiian name befitting its heavenly scale. Laniakea, meaning immeasurable heaven. Our cosmic address had been rewritten. We were residents of the Laniakea supercluster, and the Great Attractor, the object we thought was the prime mover, was revealed to be just the gravitational heart of our local basin. It is the point towards which everything within Laniakea is slowly, inexorably falling. But the new map also confirmed the lingering doubt. Laniakea, this entire cosmic continent of galaxies, was itself in motion. The whole structure was being tugged by something even more massive, something far outside its own boundaries. The search for the true source of our cosmic velocity was on again. The Great Attractor was no longer the final answer. It was just a clue, pointing the way toward an even more formidable power, lurking deeper in the cosmos. To find the source of Laniakea's motion, astronomers had to cast their nets wider than ever before. They needed to look beyond the Great Attractor, beyond the zone of avoidance. They peered hundreds of millions of light-years deeper into the cosmic ocean, and there, they found it. A structure of such staggering immensity it almost defied comprehension. It had actually been first noted decades earlier, in the 1930s, by the legendary astronomer Harlow Shapley. While surveying the distribution of galaxies in the southern sky, Shapley noticed a remarkable cloud of them, a region of space where the density of galaxies was exceptionally high. At the time, the scale and significance of this discovery were not fully appreciated. It was just one more curious feature in a universe full of wonders. But with the new understanding of cosmic flows, Shapley's cloud was re-examined, and it was revealed to be the true titan of our local universe. It is called the Shapley Supercluster. If Laniakea is a vast continent, then the Shapley Supercluster is an entire world. Located about 650 million light-years from us, it is the largest and densest concentration of galaxies in our cosmic vicinity. It contains over 8,000 galaxies, with a total mass more than 10 million billion times that of our Sun. It is a cosmic metropolis so crowded, so gravitationally dominant, that its influence is felt across the universe. This is the object that is pulling on our entire Laniakea supercluster. The mystery was now laid bare in all its magnificent complexity. Our galaxy, the Milky Way, is falling toward the center of the local group. The local group is falling toward the Virgo cluster. The Virgo cluster, and everything around it, is falling toward the Great Attractor. And the entire Laniakea supercluster, containing all of these structures, is being pulled across the universe. Its destination, the incomprehensibly massive Shapley supercluster. It's a nested, hierarchical fall, a cascade of gravitational attraction on a mind-boggling scale. We are not just on a river, we are on a tributary, which flows into a larger river. That river system forms a continental watershed, Laniakea, and that entire watershed is draining into a vast cosmic ocean called Shapley. This grand cosmic flow is a direct and beautiful confirmation of our modern understanding of the universe. It is a visible manifestation of the underlying structure that governs everything. This structure is known as the cosmic web. When we zoom out to the largest possible scales, the universe does not look like a random scattering of galaxies. Instead, it resembles a gigantic, three-dimensional spider's web. This cosmic web is composed of immense, thread-like filaments of dark matter. Galaxies and galaxy clusters are strung along these filaments like pearls on a necklace. These filaments stretch for hundreds of millions of light-years, connecting and weaving through the cosmos. Where the filaments intersect, they form dense, massive nodes. These nodes are the superclusters, like Shapley and the heart of Laniakea. Surrounding this intricate network are vast, empty regions of nearly nothing. These are the great cosmic voids, profound emptinesses that can be a billion light-years across. The cosmic web is the skeleton of the universe, and gravity is its architect. In the very early universe, matter was almost perfectly uniform, but there were minuscule quantum fluctuations in density, tiny spots that were infinitesimally more massive than others. Gravity, ever patient and persistent, began to work on these tiny seeds. Over billions of years, it amplified them. The slightly denser regions pulled in more matter, becoming even denser. Matter drained away from the less dense regions, creating the voids. The cosmic flows we observe today are simply this process of structure formation in action. Galaxies are streaming along the filaments of the cosmic web. They are flowing away from the voids and toward the great nodes. The Great Attractor is a major junction in our local part of the web. The Shapley supercluster is an even more significant continental hub. Our journey is not a random drift, but a ride along the superhighways of the cosmos. We are following the gravitational contours laid down by dark matter over 13.8 billion years. It is a process of cosmic assembly, gravity slowly building the great cities of the universe. But this grand construction project has a powerful and mysterious adversary. There is another force at play in the cosmos, one that is working against gravity, a force that is trying to tear the cosmic web apart. This force is called dark energy. While gravity pulls matter together, dark energy pushes space-time apart. It is a repulsive force, an intrinsic property of the vacuum of space itself, and critically, it is winning the cosmic tug-of-war. In 1998, astronomers discovered that the expansion of the universe is not slowing down as expected. It is accelerating. The space between galaxy clusters is stretching at an ever-increasing rate. This introduces a profound and poignant twist into the story of our cosmic journey. We are being pulled toward the Great Attractor, which is being pulled toward the Shapley supercluster. Gravity is commanding us to fall towards these immense structures, but the dark energy-fueled expansion of space is working against that command. The very fabric of the universe between us and our destination is expanding, and it is expanding faster and faster every moment. So, will we ever arrive? Will the Milky Way one day merge with the galaxies of the Norma cluster at the heart of the Great Attractor? Will our entire Laniakea supercluster eventually collapse into the Shapley supercluster? The answer, according to our best current understanding, is almost certainly no. The distances are simply too vast, and the force of dark energy too powerful. The space between us and the Great Attractor is growing faster than we can traverse it. We are like a runner on a cosmic treadmill that is constantly speeding up. We are running toward a finish line that is receding from us faster than we can run. Our local group of galaxies, bound by gravity, will eventually merge into one giant galaxy. But the great structures beyond, the destinations that have guided our motion for eons, are slipping away. They are being pushed over a cosmic horizon beyond our reach forever. In the far distant future, as cosmic expansion continues to accelerate, the universe will become a much lonelier place. Distant superclusters like Shapley will recede so fast their light will no longer be able to reach us. They will vanish from our sky as if they never existed. Future astronomers in our galaxy will look out into a universe that appears almost empty. The great cosmic web will have been stretched to the breaking point. The grand evidence of cosmic flows and large-scale structure will be gone, erased by dark energy. We live in a privileged epoch, a brief window of cosmic time where we can still see the grand narrative. We can still map the rivers and watersheds of the cosmos. We can witness the magnificent battle between gravity's pull and dark energy's push. The journey to understand the Great Attractor has been a profound lesson in cosmic humility. It has reshaped our place in the universe, time and time again. First, we learned we were not stationary, but part of a colossal galactic flow. Then, we identified the source of that flow, a hidden mass behind our own galaxy. Then we discovered that this source was itself just a local landmark in a far larger structure, Laniakea. And finally, we found that our entire celestial continent is on a pilgrimage toward an even greater mass, the Shapley supercluster, a destination we are fated to pursue but never to reach. Each step of this journey has revealed a universe more complex, more structured, and more magnificent than we had ever imagined. It shows us that everything is connected, from the smallest quantum fluctuations in the early universe to the grandest superclusters of today. Our Milky Way is not an isolated island, but a participant in a dynamic, evolving cosmic ecosystem. The mystery of our motion has led us to the very architecture of creation. We now understand that we are living inside the process of cosmic structure formation. We are witnessing the slow, majestic assembly of the universe, even as another force works to unravel it. The silent, invisible current that pulls on our galaxy is the echo of the Big Bang itself. It is the enduring legacy of gravity, written across billions of light years. And though our final destination may forever lie beyond our grasp, the journey itself is the revelation. It is a journey of discovery that continually expands our horizons. And it reminds us that in this vast, mysterious cosmos, there are always greater attractors and deeper enigmas waiting to be found. The river flows on, and we flow with it, forever falling through immeasurable heaven.